10 key tech advances we need to colonize Mars. If we want to send people to live on Mars within the next few decades, technology needs to keep advancing at a rapid pace. As early as the 2030s, NASA intends to launch its first manned mission to Mars. But before we can hope to safely visit the Red Planet, humanity will need to make some significant technological advancements. 10 water extractors. Future Mars colonists will be reliant on frozen water buried in the Martian soil, despite the recent discovery of some liquid water on the planet. It may be necessary to physically dig up that water in order to extract it, or it may be possible to vaporize the water using microwaves and then bring it to the surface as a gas. A large-scale water extractor has not yet been tested on Mars itself, despite the fact that both machines have been tested on Earth. And it's unquestionably crucial to test the equipment before thinking about establishing a permanent base on Mars. That's not just to prevent dehydration-related deaths among the colonizers. Some experts have proposed separating the hydrogen and oxygen atoms that make up the water molecules in order to use the water as a source of oxygen. The colonizers would be in danger of perishing from a lack of oxygen if that plan is carried out and the water-gathering equipment malfunctions. Water would still be required for drinking and fuel production even if a different method of supplying oxygen were employed, such as breaking down carbon dioxide from the Martian atmosphere. Such essential tools should be put to the test in the Martian environment so that any flaws can be found before they endanger lives. 9 Mars suits. The Martian environment offers many interesting difficulties and risks, some of which may not immediately result in the colonists' deaths, but may later result in serious health issues. Therefore, special suits that are even more advanced than current spacesuits would be needed for exploring Mars. To begin with, Mars is frequently exposed to lethal space radiation. The atmosphere and a magnetic field known as the magnetosphere shield us from these cosmic rays here on Earth. Only a few astronauts have risked full exposure to space radiation on short missions beyond low Earth orbit because orbiting spacecraft like the International Space Station, ISS, are inside the magnetosphere. Because a trip to Mars would take much longer, radiation protection is essential. That's particularly challenging for Mars suits, which must be comfortable to wear while also offering sufficient protection. Hydrogenated boron nitride nanotubes, BNNTs, could be one potential candidate wear while also offering sufficient protection. Hydrogenated boron nitride nanotubes, BNNTs, could be one potential candidate. Researchers have actually turned BNNTs into yarn, which could be combined with the fabric of spacesuits to provide radiation protection. BNNTs were originally created to shield spacecraft. Another issue is that without the force of Earth's gravity, the human body has a tendency to degrade. On the ISS, astronauts experience muscle atrophy and may lose up to 2% of their bone mass each month. Exercise can help with this on the ISS, but for long-term missions to Mars, MIT researchers have created the Gravity Loading Countermeasure skin suit, which gently squeezes the body to simulate the effects of Earth's gravity. The skin-tight suit enables it to be worn outside a spacecraft or on the surface of Mars underneath larger spacesuits. 8 spaceships. It goes without saying that landing a manned spacecraft on Mars will be much more difficult than doing so with an unmanned rover like Curiosity. Only a few brief manned missions have been successfully completed so far to the Moon, which is 200 times closer to Earth than Mars. However, NASA is aiming high with the Orion spacecraft. Orion, which was created with a mission to Mars in mind, should be capable of long-duration space travel and be able to send up to 4 astronauts to Mars for a 6 to 9-month mission. Orion's trip to Mars won't take place until at least the 2030s, though. With missions to the Moon and at least one asteroid, NASA will first test it. In order to propel Orion, the agency is also creating a massive new rocket called the Space Launch System. Although it now appears likely that they will be postponed until at least 2023, the first manned tests were initially planned to begin in 2021. Orion's first unmanned flight was accomplished in the interim in December 2014. The goal of the mission was to evaluate the capsule and collect data on radiation's effects. Currently, galactic cosmic ray radiation makes it impossible for humans to spend more than 150 days outside of low Earth orbit. It would take much longer to travel to Mars and back, so creating efficient radiation shields for Orion will be crucial. 7. Fuel. Orion is a relatively small spacecraft right now, but adding a much larger habitat module will be necessary to keep astronauts alive and mentally stable during the months-long trip to Mars. Such a large spacecraft would need an enormous amount of fuel to travel all the way to Mars. The weight of that fuel alone would increase the weight of the shuttle, reducing the amount of room for instruments and making it harder to escape the atmosphere of the Earth. Finding a fuel that is more efficient is one solution. The majority of spacecraft are currently propelled by chemical means. On the other hand, solar electric propulsion, SEP, is a type of propulsion system that NASA is developing by chemical means. On the other hand, solar electric propulsion, SEP, is a type of propulsion system that NASA is developing. In order to accelerate xenon atoms into an exhaust plume that moves the spacecraft forward, this harnesses solar energy. This system would be lighter than any other chemical propulsion engine. There is a problem, though. SEP engines would require more time to travel to Mars than chemical engines because solar arrays are currently unable to generate enough power to give them the same thrust. Given that we already find it difficult to keep the astronauts alive and mentally stable for the minimum of 6 months required to reach Mars, this poses a serious challenge for manned missions. As a result, some experts have recommended that supplies and equipment be transported to Mars using SEP engines that use little fuel. The astronauts could travel more quickly on a streamlined, chemically propelled spacecraft that is only intended to transport them there quickly and safely after the heavy supplies have safely landed. 6. Landing equipment. There is still an unsolvable issue. Even if we had a ship that could transport people and supplies to Mars, we simply lack the technology to land it securely. On the Moon, where there is essentially no atmosphere, we can land spacecraft. And since Earth has a much thicker atmosphere than Mars, we can easily land there. However, due to the red planet's thin atmosphere, landing even small robotic probes is extremely difficult. There is currently no way to land a ship big enough to carry people safely. The issue is being worked on by NASA, which is currently testing a setup that combines a sizable supersonic parachute and a donut-shaped air brake. A test in 2015 was unsuccessful because the parachute failed to inflate and was torn apart. However, the test yielded useful information that NASA intends to use to enhance the design. They have plenty of time to work on the issue because NASA's mission to Mars is slated to launch in the 2030s. Mars One, a contentious project that seeks to establish a private colony on Mars, intends to use a rocket-powered spacecraft that slows down on its own without using a parachute. Since this has never been attempted before, experts have called the entire Mars One project insane. 5. Green ticks. Mark Watney, played by Matt Damon, is depicted as a brilliant botanist who can grow potatoes in the red soil of Mars in the recent film adaptation of the book The Martian. Bruce Bugbee, an academic from Utah State University who developed the lettuce that NASA recently grew on the International Space Station, is Watney's closest contemporary. According to Bugbee, The Martian's basic ideas were accurate, but the film overestimated the challenge of cultivating plants on Mars. First off, only 60% of Earth's sunlight reaches Mars. Additionally, even more light would have been blocked by Watney's radiation-shielded habitat. According to Bugbee, in order to focus the sunlight Mars does receive, a farm on Mars would actually require an artificial light source or a system of mirrors and fiber optics. Plant cultivation on Mars would be extremely challenging, according to Bugbee. Given that the soil on the red planet is rich in iron oxides, it makes sense that it is quite rusty. Because this oxidized soil is unsuitable for supporting plant life, Martian colonists would either need to cultivate their crops hydroponically or treat the soil to reduce iron oxides and increase fertility. But because of the work done by Bugbee and others, future Mars visitors should have everything they need to cultivate edible plants both during the trip there and once they arrive. A few months ago, Scott Kelly, an astronaut, became the first person to consume lettuce harvested from space. It was supposedly delicious. For builderbots. We cannot simply drop people off on Mars with no support systems in place and then expect them to construct everything they require. All practical colonization plans call for the deployment of supply-laden unmanned ships before humans, along with robots to carry out necessary preparations. For example, long before the first human stepped onto the red Martian soil, robots could build habitable habitats and start extracting water from the ground. The issue is that we haven't yet created these builder robots, and the Mars-capable capabilities of the robots we can currently create are rather constrained. Currently, NASA is collaborating with 2 universities on the R5, a humanoid robot. Bipedal robots, some claim, are not the best option, preferring instead the use of 4 legs or, better yet, tire treads. Additionally, proponents of robots have argued against overburdening our mechanical workers. They contend that we should simply complete as much work as we can here on Earth. For example, rather than having to build a robot from scratch, we could set up prefabricated inflatable shelters. The bots could then concentrate on easy tasks that don't require problem-solving abilities or fine motor control. 3 homes. Designing specialized habitats for the colonists will undoubtedly be a crucial step in the process of colonizing Mars. It will be necessary to pressurize these habitats to near-Earth conditions. They will also need to take precautions against radiation, icy weather, and dust storms. And since future Martian colonists will probably spend a lot of time indoors, they'll need to feel comfortable. And there would be even more unexpected difficulties with life on Mars. For instance, it makes sense that Martian colonists would cultivate palatable plants in their living spaces. The issue is that plants produce oxygen, which would accumulate in a closed environment to the point where the air would become poisonous to people or everything would catch fire. And it's challenging to release too much oxygen without also losing priceless nitrogen, an essential component of the atmosphere. Engineers will therefore need to create a reliable system for removing extra oxygen under Martian conditions before any space farms are feasible. In the end, it's too early to speculate on the design of a home on Mars. However, some of the opportunities are breathtaking. NASA held a contest to create a Martian habitat in 2015. One of the few, the winning entry, ignored the planet's red soil. Instead, they suggested a towering triangular structure made entirely of Martian ice, which was an equally abundant resource. Maternity wards, too. In general, having sex while on a mission is prohibited for astronauts. But it's difficult to imagine sending groups of people to Mars for the rest of their lives and having them all remain celibate. And with sexual activity comes the chance of getting pregnant on Mars. Since it's completely uncharted territory, extra safety measures would probably need to be taken to protect the mother and child. The main issue is radiation, as usual. Radiation can seriously harm the DNA that regulates embryonic development. A child conceived during the trip to Mars would therefore almost certainly be sterile and have a high risk of having birth defects or mental retardation. The situation would be easier to handle on Mars itself, but extra care would undoubtedly need to be taken to protect expectant mothers from radiation. Even the idea of settling colonists in a crater on Phobos, a moon of Mars, has been floated. Some crater walls on Phobos block 90% of cosmic radiation. It is also obvious that a child raised on Mars may grow differently than a child raised on Earth. One of the few studies on the subject involved sending pregnant rats into space, where they were then brought back to Earth to give birth. The new baby rats didn't have a proper sense of up and down due to their development in zero gravity. but the effect vanished after a few days, showing that space babies can adjust themselves to normal gravity. After all that, it might not be as urgent to worry about the pregnancy in space after all. According to researcher Joe Tash, long stays in low gravity may seriously harm both the male and female reproductive systems. If so, a lengthy journey to Mars would compromise the first Martian's ability to reproduce. On a way home with no plans for a return to Earth, the Mars One project wants to send colonists on a one-way trip to Mars. Which is probably for the best, because an MIT report claims that the Mars One colonists will pass away almost right away. Also, although purchasing a one-way ticket to Mars might sound romantic, colonizing the solar system without trapping people on Earth is probably not the best course of action. Thankfully, NASA has considered a return trip for its Mars mission. This obviously presents a significant technical challenge. Unexpectedly, the return trip to Earth is relatively simple. A spacecraft known as the Earth Return Vehicle will remain in orbit around Mars until it is time to return the astronauts to Earth. Getting the astronauts to the Earth Return Vehicle is challenging. It would take years to produce enough propellant to push through the Martian atmosphere and into orbit. The Mars Ascent Vehicle, MAV, which will travel to Mars before astronauts do, is NASA's proposed solution. The MAV will automatically start removing carbon dioxide from the atmosphere and turning it into fuel as soon as it touches down. The MAV will likely need about 2 years to fill up, and the astronauts won't leave the planet until NASA receives word that there is enough fuel to return them to it. The MAV must therefore be durable enough to endure the hostile Martian environment for up to 4 years. For the mission to be successful, NASA anticipates that it will be the heaviest object they will need to land on Mars. Making sure the first Martians have a way home will be worthwhile, though. That's for now. We appreciate you for being here. View more our channel videos.